Hey YouTube, Jay Kilroy here, Little Shop ADHD, and we truly have a befuddling selection, sure to send anyone off into kind of mumbling dizziness when we cover all the topics we're going to cover today. We're going to talk about unusual work holding. We're going to talk about some new tooling acquisitions. We're going to talk about drilling big holes, how to do it when you don't necessarily have a large horsepower machine. We're going to talk about this cool item here, this work plate that I acquired recently. We're going to talk about that. And kind of catch on what's going on in the shop. I am air conditionless at the moment. Yeah, you heard me right. We'll get back to that in a moment. Also, I got new stickers. I don't know if I noticed this. I got new stickers. And I got new shirts. Whoop. We'll kill Roy with here. I got new shirts, got new stickers. I will put some information down below in the description. For those of you that want stickers, you send me an address and I'll send you a sticker. For those of you that want shirts, more information down below in the description. We're getting ready for the bash coming up, and I had to get a fresh batch of shirts and stickers made. First thing, let's talk about some unusual work holding issues, kind of things you don't run into, maybe not run into every day, but nonetheless a pain in the butt. So I'm going to move the camera around and we're going to talk about some stuff over here at the drill press. All right, what you got here? This is a 12 by 12 steel JIC box. I use these for some products. And these are a booger to deal with, right? You know, if you normally just put these on a bench and mark these out and drill these by hand, you know, they're just heavy enough a gauge to make drilling them a pain, especially if you're drilling somewhat larger holes. We use gland fittings in here. Like so. These guys, of the holes that are drilled in here, this is one of them. There's 4 of these that go in here. So what I've got is I've got this little setup to hold the JIC box from the drill press. So I just have this piece of plywood. Sitting it straight down on the table is a problem because of this ledge, the mounting flange. Also, you know, the drill press table might be oily or whatever, might have chips and stuff on it, and I don't want to damage the finish on the as factory box. You'll notice the slot cut in here for the mounting flange to go down into, and this backing block, and here this block here. So this just goes in here. And then I got a little toggle clamp that holds it down. That's really not all the holding you need down for it, but if I want to do several of these, what I do is I set my stop on my production table so it stops in this line. This is where all the holes are going to go. And then I'll set a stop 2 inches from this side of the box, 2 inches from this side of the box. And this is where the 2 outer holes are going to go. So no big deal there. So to drill these, once it's in here, unit bit, you got to kind of ease it through. See, it still moves around. It's not just sitting like, now there's a stop set here on my depth stop. Right there. There's a depth stop set here on the drill press that stops me at the right step. Now these things leave a terrible burr, absolutely terrible burr. But when you put your gland fitting on through here, like so, it's a snug fit. Take your plastic nut here, run that down. That burr is actually functional. It'll actually grab the underside of that plastic nut and tear into it. And as you tighten that nut down to pull that gland fitting in there tight, it's like Loctite for plastic. It grabs that, the burr grabs this nut, and it will not come loose. So don't deburr it before you put that, if you're using this style, commonly available gland fitting. Don't deburr it. And then run it over to this end, same thing. There you go. You know, these chips are hot, and these unibits leave yourself a pretty sharp, like I said, pretty sharp, jagged burr. And some of these you got to kind of manhandle a little bit. Whatever you do, if you try to drill through one of these with a regular bit, with a regular drill, split point, you know, I mean, you know what happens when you're trying to drill thin material. It's grabby, it wants to grab, it doesn't cut a clean hole. It's really difficult to get started in center. So these unibits work well in the drill press. So anyway, I just wanted to show you this setup. It is not a bad setup for working with these kind of items. If you're going to be doing box modification, building little setups like this is nice. On the back of this one, it says 12 by 12 JIC, right? So I take it from here when I'm done with it. I go stick it on the shelf, and when I need it, I just go over there and grab the right one, and it's already set up ready for the 12 by 12 JIC. All right, so there you go. Unusual work holding. If you work with electronic enclosures, you know, it's such a pain. Do you drill it? Do you punch it? Just, you know, they're a pain to work with. Real quick, got some stickers to add to the collection. Maple Lane, from Maple Lane Machine and Tool, from my buddy Brad Jacob. Let me peel this baby off here. And come on. There we go. Let's add this to the front of the case. About right there. All right. And the other one I got here is Jim Trek from Mr. Bruce Whitman, all the way from Perth, Australia. It's kind of big, so let's see. I think it'll go right there. Let's try that. Perfect. Perfect. Met Bruce at last year's bash. Great guy. Great sense of humor. You know, just like the rest of us, he appears in person exactly the way he does on video. He had a couple of other little goodies. This Toledo stainless rule, it's actually right over there at the drill press, is made in Australia that I now use all the time. It's a flexible rule, metric on one side, imperial on the other. I use it all the time. Very handy. He also had these books, the little black engineering books you've seen the other folks talking about, and I use that all the time as well. Looking forward to seeing Bruce again at the upcoming bash. So, Bruce, if you're out there, I was just watching your video on your welding positioner build, so I'm following you, you know. So looking forward to seeing everybody at the bash. Brad, looking forward to seeing Stan, looking forward to seeing Adam, John, everybody. The bash is kind of like my yearly pilgrimage. So what we're going to do right now, we're going to talk about this thing. I don't know what you would call it. I bought this on eBay. I bid on it. There were two of them. I bid on both, only got one. And didn't come with any paperwork, any information as to who made it. There's no maker's mark on it, but somebody certainly put some work into it. It's kind of like a bench block, except you'll notice what he did. I'm assuming he could have been a she, certainly. There are square notches cut in the end here, and then there's a plate bolted to the end of the block. So it's whole thing is 5/8 of an inch thick. It's hard on all surfaces. It was surface ground on all surfaces, and it has all sorts of holes in it here. So for the square holes, there's 1/8, 1/4, 3/8, half, 5/8, 3/4, and 1 inch. And then on just the regular round holes here, there's all sorts of sizes in here. Not all of them that are, you know, would you measure and say, oh yeah, 5/16, right? So I saw it and I kind of thought of Tom Lipton's series he's been doing on toolmaker made tools. I have a weakness besides just screw plate sets. I have a weakness for toolmaker made tools, and this is certainly pretty interesting. I have never seen one like it before. Usually when you see something like this, it just has round holes in it. So I'm going to bring the camera around so you can get a little better look at the construction. It's very obvious from the feel that this was all made, the ends were bolted on, and then the whole plate was surface ground on both sides, because you cannot tell where the surface of the block and the surface of this end cover, I guess you would call it, where they leave off. So I'm going to bring the camera over here so you can see this. There you go. These are handy to have, especially if you do work on mechanisms, if you do firearms work, being able to set something down and tap out a pin or tap in a pin for that matter. There you go. I think I paid a grand total of about $30, $34 for this. You can see where there may be this little corrosion, a little surface rust. I don't know if they had cleaned it up or not. Whoever I bought it from, where they got it from, no idea. If anybody has any ideas, feel free to let them fly. But this is something I've had sitting here, I've been meaning to talk about, and I've used it several times, and it comes in quite handy. The next tool acquisition for the shop comes from our buddies at Shars. I know it's a discount tool vendor, but you know what? I've never had any problem with you guys at all. I bought a while back a ER40 collet holder for the big mill, and I've used it extensively. And because of that, I have been wanting an ER40 collet holder that I could use in the tailstock of the lathe. So, because ER40 collets are great work holding devices, and they've got a wide range. You know, one set you can cover with, 20 ER40 collets, you can cover what you could hold probably 60 5Cs. So this is a Morse Taper 3 version here, and this is a Morse Taper 4. And like I said, ER collets are nice. So I could use this in the drill press as well as in the tailstock of the pacemaker, which I need to get back on because all of y'all are going to pester me about it here momentarily because I mentioned it on a video. So I will do so. My only complaint with ER40 collets is how tight you have to tighten the little buggers. Supposedly, the proper spec torque for ER40 is like 140 foot-pounds. So you really got to reef down on them. One of the things I told you we're going to talk about today is drilling big holes when you don't necessarily have a high horsepower machine or a larger drill press and you want to drill a big hole. How do you do it? I'll show you the way. This is the way that I've currently been drilling big holes, right? Annular cutters. And these are great. These are fantastic. The upside, these things cut great. They leave a super finish. They are easy to use. They don't require a lot of headroom. They don't require a lot of horsepower. So these are fantastic tools. The downside, well, one of the downsides is that's 2 inches that you've got depth of cut. Maybe they may come up to 3 normally. Anything past that is kind of like special order. 1 inch isn't very uncommon. So that's one of the downsides, is reach. The other downside is, that's a minimum of $100. Absolute minimum of $100. And there you go. It's a great tool, but it's a minimum of $100. The other downside is difficult to sharpen. I don't have a machine that'll do it. There are people that'll do it. I pretty much have to send this out to even have an attempt at sharpening something like this. So how did I drill big holes before annular cutters entered my repertoire? Well, allow me to show you. These are APT Multitool setups here. I got a couple of them here. They're both the same series. This is the E series. This one here is a R8 shank that you can use on a Bridgeport, and this one here is a Morse taper shank that you can use on a drill press or Morse taper machine, or in a machine with a Morse taper adapter. And how do these work? We're gonna do a demo cut here in just a second, but we're gonna go over it. So it's basically a piloted setup. You're gonna have a piloted setup. Your first size hole is gonna be 1 inch. Right, so this is the minimum size. So you're not going to use this setup unless you're drilling larger than 1 inch. So first thing you're gonna do is you're gonna drill a 1-inch hole. That hole size matches the diameter of the blade holder. So you're gonna drill a 1-inch hole. Then what you're gonna do is either you're gonna grab a blade that's gonna be, say, on size to what you want to drill. Here's a 1 9/16, and you're going to slap this in here. You're going to slap this in here. Oh, we're going to get in there. All right. There's a reason that set screw goes so far up in there. It centers the blade. So there you go. You drilled 1 inch. Then you can take this piece here. You can pilot off the inch size hole, and then you could drill the 1 9/16, and you're done. Okay, that's if you're going to go one step, right? If that's the biggest hole you want to do. But what if you wanted to drill something bigger? So what you would do is you would find your 2-inch. Here's the 2-inch blade, right? You're going to take the 2-inch blade. You're going to stick the 2-inch blade in here. In there. Okay. You're going to tighten that down, then you're going to drill from 1 inch to 2 inch. Cutting edge on both sides there. Again, you're going to pilot off the 1 inch, then you're going to drill to 2 inch. And then, okay, if you want to go to 2 inch, you're done. But let's say you needed something bigger than 2 inch. Then what you're going to do is you're going to loosen this up again. Take your 2-inch blade out. Let's say your final hole size is going to be 2 3/4. Here's your final hole size. So you've drilled a 2-inch. Then what do? You take your 2 3/4, you slide your 2 3/4 in here, tighten it up. That set screw is going to center it and clamp it down. Okay. Then you're going to take your 2-inch pilot. It's going to pilot on the 2-inch hole. You're going to stick that right here. You're going to take this flathead cap screw. You're going to put that in there. And you're going to tighten that down. And then what you're going to do is you're going to pilot off the 2-inch bore, and you're going to drill to 2 3/4. Now you can do this process. You could go from 1 inch to 2 inches, from 2 inches to 3 inches right here. Or no, excuse me, this is 2.5 inches. From 2 inches to 2.5 inches, and then to 2 3/4. Or you could, depending on the material, if you're using aluminum, you can go straight to a pretty large size. But this pilot supports the blade and centers you in the piloted hole. You can see where this one's seen pretty significant use. And so you can step up. You can sit here and step up size to size to size until you can cut some pretty impressive hole diameters. I think the biggest blade that I've got is maybe this one. I don't know that I've ever used it. Yeah, I've used it. This is 4 inches. So I can go all the way up to 4 inches diameter. So it's pretty flexible. Now the other thing that's really flexible about this setup, let me go ahead and take that nut out, is that, you know, one of the things we talked about with the annular cutter is they're difficult to sharpen. Okay, not these. These are not difficult to sharpen. Let's look at the blade here. See, you've got just a plunge grind right here and a plunge grind right here, and that's your cutting edge right there. Here is your sharpening jig right here. Hold this right here. You could use it in a surface grinder if you want to. You can drop this in a surface grinder. You can plunge straight in and you can touch this up, or you can use this on just a regular bench grinder. You can touch one of these up on a regular bench grinder with this little jig right here. The other really cool, and I've only done it a couple of times, but what you can also do is you can resize these blades if you have a custom size that you need. There's an arbor here. Uh-oh. I think I let things get kind of funky. There we go. You put your blade in here. This goes through here like so. There we go. You put your blade in here. You tighten it down as normal from the end and set this up. And then you can put this in the surface grinder and you can trim off each end, rotate, and you can create a custom length for a custom application. These blades are pretty cheap. I mean, they're not terribly expensive. It's been quite a while since I've purchased one, so I'll be honest, I don't know. I know they still make this. APT still makes these, so they're still available. But I'll be honest, I no longer know what one of these would cost new. And but so you can do custom sizes. It's it really easily. You're not going to do a custom size annular cutter. You're not going to do a custom size. You can do a custom size drill bit by grinding down the point and the flutes of a drill bit. You can do a custom size drill bit, but this is for a lower volume application. This is the way to go. Now this is the Series Series E set. Both of these, and they start with a 1-inch pilot. There's a smaller series of these called the Series D that you start with a 3/4 inch pilot hole, and then the blades are a little thinner, but other than that it works exactly the same. There is there's no difference. You start with the 3/4 inch pilot hole, then you can, I think you drill up to 1.5 inches, use an 1.5 inch pilot, then you drill up to 2, use a 2-inch pilot, you can drill up to 2.5 inch pilot. You can still do a pretty large size hole, and these will run in, this will run in an R8 machine. You're not normally going to chuck up a 4-inch drill bit in an R8 machine. So this does allow you to drill fairly decent sized holes with a low power machine. We're going to kind of go through the process. We're going to start off with an 1-inch pilot hole. Then we're going to drill up to a 2. We're going to throw the 2-inch pilot on. And then we're going to choose some size bigger than this and drill a hole bigger than this. Let me go find a piece of material and we'll get set up in the drill press and we'll go. All right, we're going to start with a 1-inch hole. Whoop. I dropped my float lock vise and it landed on the off button. All right. Get all those chips out of the way. There we go. All right, lube is your friend. All right, you should have a nice snug fit with the pilot. Now right off the bat, let's stop and look at something right quick. Right off the bat, it's pretty obvious that these work excellently for doing counter bores, for doing, flat counter bores. These are fantastic. Matter of fact, APT sells a whole line of these with the blades cut backwards, and you turn the blade around. In other words, the cutting edge is opposite of that notch. Let me get one. You notice here, the cutting edge, this notch, the locating notch and the cutting edge are on the same side. So I'll put it in here, I locate it. I'm pretty much destined to only be able to work in that direction. They make a whole nother series of these blades with the locating notch on the opposite side from the cutting edge. So you would have it mounted in like so. So that is for doing backside spot facing. So you can set this, you can run this through a hole, you can mount the blade, and then you can pull back and you can do backside spot facing, and it works great. You can also spot face obviously this way as well. So these work great as spot facers. That's something you can't do with an annular cutter, and you can't do with a regular drill bit unless you want to be one of those folks that grinds a flat on the end of a bit. You can spot face these and it works fantastic. Had to change batteries there. I'm not working it real hard here. I'm not pulling down real hard, but you see it's throwing a nice chip. That's some A-Bomb approved dark cutting oil. I'm running in low range, probably around 100 RPM, I guess. Breaking through. Let me get some stuff out of the way so you can watch the process. There you go. So we started with 1 inch. We went directly to 2 inches. So I'm going to change the blade, and I'm going to change the pilot, add the accessory pilot, and we're going to size up. All right, so we changed over. Got the 2-inch blade out. We have the 2-inch pilot in. We have a 2 3/8 inch blade in the cutting position. So now we're just going to come down, keep on doing what we've been doing. Plenty of lube. But remember, you're not just lubing the cutting tool here, you're also lubing the pilot. Grip. There we go. So we went from inch to 2 inch to 2 3/8 inch, and that's really pretty easy, folks. That's pretty straightforward. Again, a lot of things you can do with this you can't do with an annular cutter. You can spot face for one. You can do blind holes for another. You have to accommodate the pilot length, but you can still do a blind hole. You can't do a blind hole with an annular cutter. You can do flat bottom holes very easily, obviously. And in aluminum, you can go directly from your 1 inch pilot up to like 3 inches, right? Without actually having to pilot again. There's a lot of flexibility. The holes are very much on size. It's a very controlled process, as you saw. It doesn't require any really special hardware or outrageous machines. And I haven't really looked, but I would expect that these things are probably all over eBay. They're easy to sharpen, easy to modify for custom size holes. So anyway, APT Multitool right there. You want to drill big holes, here's a way you can do it.